Discrete random variable. A couple has two children. Define the variable x to be the number of girls. Find the probability of each of the possible values of x. Construct a probability distribution value. First, since the couple has only two children, we can list the sample space that consists of all of the possible outcomes. If we let B represent boy and G represent girl, then we have in the sample space boy, 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 girl, girl, boy, or girl, girl. There are four possible outcomes. To list all of these possible outcomes, we might want to start with a tree diagram. Since the couple had two children, there are two stages. The first stage is for the first child. There are two possibilities only, even though the couple has one first child, boy, girl. We do not assume twin or triplets or any other variations. Then comes the second stage. If the couple has boy the first time, then the second time the couple might have either a boy or a girl. The same thing. If first the couple has a girl, then the second time the couple might have either a boy or a girl. And there it is, boy, 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 girl, girl, boy, girl, girl, all four possible outcomes. However, in this case, x is defined to be the number of girls, and so if we look at the first outcome, how many number of girls in there? None, 0. If we look at the second possible outcome, how many number of girls in there? Well, 1. In the next possible outcome, again, how many number of girls? 1. And in the last outcome, how many girls in that outcome? 2. And so we say that the possible outcomes for x, where x is defined to be the number of girls, x can only be 0, 1, or 2. 0 girl, 1 girl, or 2 girls. What are the possible outcomes where x is 0? That is only when they have boy, boy. What are the possible outcomes when x is 1? That is when they have either boy, girl, or girl, boy. BG represent a boy and then a girl. The first child is a boy and then the second is a girl. And GB represents the first child is a girl, the second child is a boy. But regardless, there are two possible outcomes when x equals 1. And when x equals 2, there is one possible outcomes. Now, if we can count that, then we can find the probability of each of the possible values for x. In some cases, we might have to make a table, a t-chart. Now, this is not the probability distribution table. In this case, there are only 4 possible outcomes, so this is quite simple. In a more complicated scenario, we might have to make the following table. We list the possible outcomes with the corresponding probability, and we also list the possible value of x for each of these possible outcomes. For example, for the outcome BB, what is the probability to get BB here? Remember that the events of getting the boy the first time or getting the boy the second time are independent. And so if they're independent, we can multiply their probability. The probability of getting a boy the first time, 50-50, 1/2, times, because they're independent, times the probability of getting boy the second time is 1/2, and so that is 1/4. X is the number of girls. In this case, x equals 0. Same thing. BG, the probability of getting the boy the first time is 1/2. Getting the girl the second time is 1/2, and so that probability is 1/4. X equals 1 in this case. GB, the probability of getting a girl the first time is 1/2. Getting the boy the second time is 1/2, so that is 1/4. the number of girls, X is 1. And for the last outcome, GG, the probability of getting a girl the first time is 1/2, getting the girl the second time is 1/2. We multiply them because they are independent. What is the number of X in this case? 2. And again, this is quite simple, we got them, but in some cases we might have to construct such table. Now, we're going to construct a probability distribution table that lists the possible value only once. And so we're not going to list the outcomes themselves. We only list the possible value for X. Now, the possible value for X in this case are 0, 1, 2, and we list 1 only once. So this time, this is a probability distribution table. We list X, and then we list the corresponding probability for X, where we write P of capital letter X equals the lowercase x. What are the possible values of X here? 0, 1, and 2 only. There are 3 possible outcomes for X. What is the probability that X equals 0? Well, we found it. It is 1/4. What is the probability that X equals 1? There are 2 cases, and each has a probability of 1/4, 1/4, and there are 2 of them. And so 2/4 for X equals 1. What is the probability with X equals 2, meaning the event that the couple has 2 girls, and that is 1/4. This is what we call a probability distribution table. Each of the corresponding probabilities had to be a number between 0 and 1 inclusive. The probability table lists the possible value for X with the corresponding probabilities, and even with repeated value of X, we only list this one and add up the total probability for any given X. The sum of the probabilities in a probability distribution need to add up equal to 1. And that is the reason why we left this at 2/4 instead of 1/2, so that we can see 1/4 plus 2/4 plus 1/4 is 4/4, and 4/4 is 1. After we realize that, we might have to change this 2/4 into 1/2.